Major spoiler alert, I'm going to give you the answers to the 8 review problems from Monday. So if you haven't done those problems yet, don't be a slacker. Turn these off and go back and do them. Those 8 problems are real similar to what the formatives would have been like. So I don't know if you're going to end up having to take those someday or not. So this is really good, not only good practice for you, but it's important to know if you're ready to move on or if you need to study these first 2 weeks more, because these are tough problems, some of them, over on what we've gone over the last 2 weeks. So here you go. These were the 5 problems on the week 1 review. So problem 1, it gave you that this angle down here, ABC, was 80 degrees. This arc from A to B was 4x plus 8, and this arc from B to C was 120 degrees. That was given. And it asked you to find what was x, solve for x. So whenever you have an algebraic expression in an angle, you got to figure out how many degrees are in an angle. And if you have an algebraic expression on a line segment, you got to figure out how long is that line segment. If it's on an arc, what's the measure of that arc? And then whatever those numbers are, you set the 4x plus 8 equal to that. We've done plenty of problems like this all year. You guys know how to do that. So we need to find the arc of AB. Well, one way to find an arc is to find an angle that goes with it. Well, there is no angle that goes with arc AB. So you had to use a different strategy on this one, which was the fact that there's 360 degrees in a circle, and this circle is broken up into 3 arcs. If we could figure out the other 2, we could figure out how many degrees are in the third one, because they have to add up to 360. And we can figure out the other 2. The one is given, and the other one, AC, that we don't have, it's going to be double this angle B here, which is 80 degrees. Because remember, the on, if your angle is on, the vertex is on the circle, then the arc is twice as much as the angle. So that arc AC is 160 degrees, which means the 2 out of the 3 arcs add up to 280, because 160 plus 120 is 280. So the only amount we have left here is 80 degrees. 280 plus 80 is 360. So 4x plus 8 was equal to 80, because that arc AC was 80 degrees. 80 plus 160 plus 120 is 360. And then it's just simple solve for x. Subtract 8 and divide by 4. 72 divided by 4 is 18. So x was 18 on that one. All right, the next one, I might have these out of order here, but the one was just a triangle inside of a circle, and it gave you 2 out of the 3 angles inside the triangle, and it asked you to find this arc right there. They wanted to know what was that arc. Well, that arc is going to be just like this one was 160, because that angle was 80. This arc is going to be twice as much as this angle over here. And we can get that angle because of the triangle sum theorem. These two add up to 105, so that angle must be 75 degrees, because 75, is that? Yeah, that's right. 75, 50, and 55 add up to 180. There's 180 degrees in a triangle. This arc is across from is what's intercepted by the 75-degree angle that's on the circle, so that arc is 150 degrees, twice as much as 75. All right, this one was just basic formula right here. What is the angle that's inside the circle when you're given the other 2 arcs? That angle is going to be the sum of those 2 arcs divided by 2, the average of those arcs, basically. So you add those 2 arcs up to get 140, and you divide by 2 to get 70. So that angle is 70 degrees, but the question was, what was this angle right there, BEC? So 70 is not your final answer. 70 and that angle right there are a linear pair, so the answer to this one was 110 degrees, because they add up to 180. All right, all the information you were given on this one is that AB was a diameter. So you're asked to figure out how many degrees are in angle C right there. Well, if AB is a diameter, it splits the circle in half. So that means this arc right here from A to B on the top was 180 degrees. And just like this first and second problem, C is on the circle and it intercepts that 180 degree arc. So that arc is twice as much as that angle. So that angle must be a 90-degree angle. And that always works. I could have drawn this triangle. If I have a diameter, I could pick C as any point on the bottom part of this circle. I could have picked C way over here. Say that's C, and I connect it to A and to B. C is always going to be a 90-degree angle because it's intercepting a 180-degree arc. So it's kind of a cool little theorem. All right, this last one I meant to be as tricky as possible. So hopefully you had to struggle with this one a little bit. I gave you three things. I gave you this big obtuse angle, BDE, is 130 degrees. This little angle out here was 30, and this arc was 70, and I asked you to find the arc of BC. So where do you even start on this one? Let's try and use the outside the circle, the angle that's outside the circle theorem. So that means you subtract these two arcs, the big arc and the little arc, divide by 2, and that's going to be equal to 30. So 70 degrees, this arc, minus the little arc right here, and then divide that by 2, and you're going to get 30 degrees. Well, what do you have to divide by 2 to get 30? I don't think I copied this problem down correct now that I'm looking at this. Yeah, I think actually I copied this down wrong. Sorry. This should have been, this was a 100-degree arc out here. All right, so that's a 100-degree arc out there. So we need, for our difference of the big arc minus the little arc, to be 60 degrees, because then we divide 60 by half and to get 30. So what are we gonna subtract from 100 to get 60? 40. So this arc right there was 40 degrees. All right, we're almost there. We figured out 40 degrees, but we need BC, not CD. Well, B all the way to D, that arc right there, is going to be twice as much as this angle A. So if we can figure out how much that whole arc is, we can subtract 40 from it, and what's left is BC, and that'll be our answer. So if we can figure out that angle right there, then we'll be good. And, oh, I know what I did. I wrote 70 there, but actually what I gave you was this angle at B was 70 degrees. And since this one was 130 degrees, linear pair says that much of it is 50 degrees. So in our triangle ABD, this must be 60 degrees because they have to add up to 180. So then this whole big arc from B to D was 120 degrees, and that much of it was 40, so BC was 80. Now there's a lot going on in this problem, and some of you may have found a different way to come up with the fact that that was 80 degrees, but that's the way I imagined it, and that's the only way I can think to do it, even though there may be another way. So hopefully that made sense, and you were, some of you, not a lot of you turned in your homework yet, but the ones that did, a lot of you were getting 80 degrees, so that was impressive. Good job. All right, the week 2 review only had 3 problems on it, and I've already written out all the answers here. So the first one was a 150-degree angle and a 6-inch radius, and they wanted to find the shaded region. So a common mistake on this one are people do 150 over 360, but the 150 is the unshaded region. The shaded region is 210 because there's 360 degrees in a circle. So if part of it's 150, the other part must be 210 because they add up to 360. And then 36 pi, well, that's just area of the whole circle is 36 pi. So we want 36 pi, radius squared, 6 squared is 36, times the fraction that we're interested in, which is 210 out of 360. So 36 and 360 reduce to 1 and 10. 210 over 10 reduces to 21. 21 times pi is 21 pi. And this one you could leave your answer in terms of pi. So 21 pi was the answer. Second one you could leave in terms of pi as well. This one was an arc length, so that is represented by the letter S, and it was this arc right here that you were supposed to find. How long was that arc? So that arc is 30 pi, pi times diameter. I gave you the radius was 15, so the diameter is 30. So the whole circumference is 30 pi, but we just want to know 72 out of 360, which reduces to 1/5. So we just want to know the circumference of 1/5 of the circle. The arc is 1/5 of the circle. So it's 30 pi times 1/5, which is 6 pi. All right, this last one was a tough one, and this one I explained how to do in the video from, I think, last Thursday. Wednesday or Thursday. I'm not sure which day it was, but the title of the video was Algebra of an Arc. So if you don't know how to do this one, I recommend rewatching that video. But it basically says what I'm about to explain to you here in more detail. Shows you the formula and everything. All right, you're given a length, an arc length, and you want to know the radius. So we gotta use our arc length formula just like we did in the problem before here. S is equal to pi times d times theta over 360, where theta is the central angle. So theta up here was 72 degrees. Theta down here is going to be 40 degrees. So I substitute in the numbers. My arc length is 20. My central angle is 40. And then I start solving for d, diameter, because we want to know the radius. Well, r isn't part of that formula, but d is, and d is twice as much as r. So if we could figure out what d is, we could just split that number in half at the end and you'll have r. So to get d by itself, I reduced 40 over 360 to 1/9. I multiplied 9 to the other side, so I have 180 equals pi d. Then I divide by pi, and that's what d is 180 divided by pi. So if you use your calculator, it's 57.32 is the diameter. You split that in half, you get 28.66, and that's your radius. And I think this one actually, the homework said to round your answer to the nearest tenth. So 28.7 would have been the correct answer on that one. All right. Hopefully you attempted those before you watched that and that it helped and you're all smarter for it. Good job.